Today, I'm going to be describing to you end-to-end data validation strategies in Fabric. And so by the time that you leave through that door or curtain in the next 50 minutes, really I want you to understand the importance, in my view, of data validation and data quality, and how in Fabric it makes it easier than ever. So I think it should be right at the heart of your Fabric data strategy. And we're going to be walking through a number of different architectures, ways of looking at things, and even at an enterprise scale, how we can monitor data quality across your whole organization so that you can build solutions that you really, truly trust in and you believe in, because that is one of the biggest problems that I see in BI and data engineering currently. So how are we going to be doing this? Well, we're going to start by looking at, again, why I think data validation is so important. We're then going to look at what can go wrong. So in our life as data engineers or analytics engineers, quite pessimistic people, we need to think about what can go wrong so that we can guard against it, so that we can ultimately improve the data quality as we go along in our architectures. Then we're going to go into the main section, which is really diving into a few different architectural ideas for how you can get a grip on data validation, specifically in Fabric. We're going to look at 3 key stages in an end-to-end pipeline and how you can validate your data at each of these stages. We're going to look at different tools that you can use. One of the best things about Fabric is that you can integrate a whole ecosystem of Python tooling. So we'll look at some of the main open source tools. Now this is quite interesting because you don't hear a lot of Microsoft employees talking about data quality and data validation because there's not many features actually built into Fabric for that. But because we can tap into that Python ecosystem, I think it's so important, and that's why I'm talking about it at this conference. Finally, towards the end, we'll be looking at some enterprise scale monitoring systems that we can build, looking at how we can tie into other Fabric features like Data Activator, so that we can get notifications and alerts through our failures. And we'll also be looking at how we can tie into other Fabric features again, this time in terms of the data governance. So we're going to be talking at quite a strategic level, lots of diagrams and pretty pictures. Want to cover as many ideas and strategies as possible, so there's not going to be much coding. But I am kind of an implementation guy. So, and I believe that the best strategies come from implementing things. The devil is in the detail. So as well as the slides that I'm going to be presenting today, I'm also publishing 3 implementation notebooks to get you started with data validation, data quality monitoring in Fabric. And right about now, there will also be a video on my YouTube channel that explains all of these things in detail, including the implementation notebooks, and a video of everything that I'm talking about here. So make sure you grab that if you're interested. So who am I? I'm Will. I've been working as a data professional for about 8 or 9 years. I've been lucky enough to work across a variety of different industries in that kind of data space, like business intelligence, data science, data engineering, data warehousing. And because of that, when Fabric was released back in May 2023, I started a YouTube channel, Learn Microsoft Fabric with Will. Has anyone watched any of the videos? A few people, awesome, thanks for your support. Now we're up to about 5,000 subscribers and it's growing every day, so that's going pretty well. There's the link if you want to have a look at that. So let's get started. So out of everything in Fabric, why have I chosen to speak to you today about data validation? Could have been anything, Spark ML, LLMs, real-time analytics, data warehousing, Spark, anything. But I'm here today to talk to you about data validation. Well, I think it's the most important thing to get right when you're moving into Fabric. You have to have that solid foundation of data quality in your organization. Otherwise, anything else you do is not going to matter, in my opinion. In some industries, regulation demands it. So if you work in financial services, then it's going to be really important because you might get audited on data quality. But if you're not working in one of these industries, ultimately poor data quality is going to lead to really bad decisions. And if your data is about the performance of your company, you know, like really high-level data and really important strategic data, if you're making poor decisions, it's going to result in a loss of revenue, unhappy customers, all of that kind of stuff. How many people here have come from a BI background, Power BI? Good, lots of people. How many times have you launched a dashboard into your business or your client, and then a few weeks later, you find out that no one's reading it? We've all been there. One of the main reasons for that, I mean, there could be lots of reasons, but one of the main reasons in my experience is data quality. If one of your clients or someone in your business goes to your dashboard, they look at the data and they can't trust it, they're not going to come back to it again, unfortunately. They might ring you up, say, I don't trust this data. And once you've lost their trust, it's very difficult to gain it back. So data validation can definitely help with that. So what I'm going to do is just describe a bit of a common pipeline here. It's kind of technology agnostic at this stage, but we're just going to get some data on the left-hand side, perform some cleaning, enrich the data a bit. Could be kind of building new columns, joining it with other data sets perhaps, building some analytical modeling, aggregations. And on the right-hand side, we're going to build a semantic model. I think this is kind of like a standard way of looking at analytics. Obviously, some people do things slightly differently, but let's just start with that. What we need to think about as kind of analytics engineers or data engineers is really what can go wrong at each stage in this pipeline. Like I mentioned, you have to be quite a pessimistic person. You have to really think hard about what can go wrong, and then build rule sets and checks to guard against all of these things. So this is a really fun game that I play most weekends called Pipeline Problem Bingo. And what I want you to do is think about, for each of these stages, what can go wrong. So when we're getting new data from a source, for example, well, the connection details could change. Maybe you're connecting to an API or some sort of external service, and they change. Maybe your token expires, the REST API isn't bringing back any data, no data at all, 500 errors, all this kind of stuff. Perhaps the most important one is that bottom one, schema changes. So if you're connecting to files in ADLS, for example, and it's a CSV or a Parquet, and you've got new columns, or they're changing the column names, for example, or the structure of a JSON that's being returned from an API is changing over time, that's something you definitely want to capture as soon as you can in your pipeline, because it's going to impact and probably ruin your downstream analytics activities. At the second stage, when we're talking about cleaning data, some things that might go wrong here, well, if you've got null values in really important columns, and by important here, I mean you're going to be using that column later down in your pipeline, so maybe you're joining on that column. Or it could be a really important date that you're going to be doing some time intelligence calculations on. If there's null values or any sort of errors in that column, then obviously that's going to impact your analytics. Similarly, with values kind of outside an expected range. So these could be numbers, or it could be dates, anything like that. That's a good protection that we can build into our analytics. Date formats. Dates are always going wrong. This is one of the main things that kind of data engineers spend their time guarding against. Data types in general. All these things are things that can go wrong, and we need to kind of have some controls over as data moves through different stages in our pipeline. Enriching the data, we can get referential integrity violations, where the unique set of one kind of key that you're joining on in one table doesn't match the same in the other table. Maybe your join logic is incorrect, you're using the wrong type of join, and that's going to introduce new data quality issues, and it's your fault, really. That might lead to something like duplicate primary keys, and that's going to cause issues again. When you're doing the analytical modeling phase, maybe you're building some SQL views or something, you might implement the incorrect business logic, or business logic that doesn't quite fit what you were trying to do. There might be issues with the aggregation granularity, and again, null values as well. And finally, in that semantic modeling phase, we can have a lot of issues with not defining relationships correctly in your model. Maybe, again, you've done the business logic, you kind of defined that poorly in your model. That could be poor DAX modeling, DAX measures, and that kind of thing. So these are all the different things that can go wrong, and this is just a short list. There could be hundreds or thousands of different things here, and obviously you need to think about the ones that make most sense for your data, your problems, and your analysis activities that you're going to be doing afterwards. So in the Power BI world, we've got quite a few people from the Power BI world here. A lot of these steps would be done in Power Query, right? You get the data in using Power Query, do some cleaning, build a nice long transformation steps and these applied steps on the right-hand side. Some of them might be 20 or 30 or 40 or 50, based on some of the Power BI developers that I've seen. But the problem with this is that it's kind of a bit of a black box, right? We get the data in one end, run through 100 steps or 10 steps, whatever, do all this different exotic joining and merging and all this kind of stuff. And out the end, if you're lucky, you get a data set that you can use in your DAX like visualization engine. If something goes wrong halfway through those steps, obviously your whole model is going to break, it's not going to refresh, it's going to be quite difficult normally to debug. So when we move to a Fabric world, we can do things a little bit differently. Again, we're going to start with the data source on the left-hand side and the kind of user on the right-hand side. And we're going to step through exactly the same process, but we're going to implement it differently. So we're going to read some data from the source, and then we might write that into a Lakehouse Files area. Then we're going to read in that data, do some parsing and cleaning, and then write it out to a Lakehouse Tables area. Again, we might read it from that Lakehouse table, enrich it a bit, do some joins with it, and again, write it out to a Lakehouse table. We might build our analytical models, and that might be done in a data warehouse if you're kind of preferring a SQL way of looking at things. And then you'll build your semantic model, and you'll output your semantic model. So the difference here is that every stage, we're kind of writing out a new data set. And that has a number of advantages. For what I want to talk about today, the data validation piece, well, we can validate at each stage in this pipeline. And this is what some would call a medallion architecture, right? I just haven't called it a medallion architecture. There's no bronze, silver, gold. It's just kind of plain language. But I think a lot of the problems with medallion architecture come from people not understanding what happens when. So try and simplify it and just make it as kind of plain language as possible. But when we can validate at each step here, over time, we're kind of progressively assuring the quality of our data as it passes through our pipeline. And we've got these data quality checkpoints now, which weren't really possible when you're doing things in Power BI and Power Query. It's kind of all or nothing. And just to kind of back that up, just to put the final nail in the coffin of Power BI, sorry Power BI users. As it's passing through different stages in this pipeline, you're not assuring the data. It's kind of all or nothing approach again. But when we implement that kind of medallion, different layered architecture, at each point, we're performing data validation, data quality checks, and over time, the quality of your data is getting higher. So on the right-hand side, your users are absolutely loving this because they can finally trust the data that you've got coming out of your gold layer, out of your last layer. So if we go back to this, how do we actually implement this? Well, for me, there's three main types of validation that we need to get our heads around. Number one is schema validation, right? And this is validating stuff that's coming into Fabric. So anything on the left-hand side, so any sort of files that you're bringing in, database data, REST API data, you need to do a quick validation that the structure of that file, or whatever you're bringing in, matches some sort of schema that you're expecting. If it doesn't, then you're going to have a lot of issues downstream on that pipeline. Number two, so all that bit in the middle, table and data frame validation. So as our data is moving between these different layers in our architecture, it's a really good opportunity to validate it. If you're doing transformations and cleaning steps, you want to validate that they've been done correctly and they've actually removed the errors that they were supposed to, or kind of the data quality issues that they were supposed to. And finally, the third one there is this semantic model validation. Now, this is kind of a new feature and a new capability, really, that is easier than ever in Fabric. Who's heard of Semantic Link here? Who's used it? Awesome. So Semantic Link gives us the capability to query what's in a Power BI semantic model through Python. And so we can then validate what's inside that semantic model. And we'll look at what that means a bit later. So we've got these three types of data validation. Now what we're going to do is have a look at them in a bit more detail, understand some tooling that we can use, understand what that looks like in a bit more detail. So the schema validation is this bit on the left. And ultimately, like I mentioned, we're trying to validate that the schema of these files and any sort of data that comes in matches our expectations. So here's what this could look like. You've got some files, Fabric tenant, Lakehouse files area. Put that in there. Can be a notebook, data pipeline, data flow. Maybe not data flow, actually. From there, we're going to read in that file into our schema validation notebook. Now, the output of that result of our validation checks might route it into two different folders, that file. Could be a passed folder and a failed folder. So if we're happy with the schema of it, put it in the passed folder. If it doesn't meet the requirements, the expectations, put it in the failed folder, we'll log it as a failure, and we'll trigger some sort of failure handling strategy. And we'll go into what that might look like at the end of the presentation. Because it's passed the schema validation checks, we can then write it into our Lakehouse, the next layer in our Lakehouse tables, right? Our raw table. We're not doing any sort of cleaning on this, so I would still call it raw. I might not call it exactly raw underscore table, but you know what I mean. That's the raw Lakehouse. And if we don't do that validation check, then if the schema does change, then this write to the raw table is not going to work anyway, probably, unless you've got some very exotic kind of catches for different structures. So inside that notebook, really we're validating the different data types, data structure, column names, number of columns, and whether it's parsable, right? Are we going to be able to parse that file and put it into a Lakehouse table? Tooling. One of the biggest benefits of Fabric, in my view, is that it opens up the entire Python ecosystem, and we can launch that on our data. And in the Python ecosystem, there are so many tools for data validation. I've listed three here: Pydantic, Pandera, Great Expectations. Each of these has kind of pros and cons. We'll talk about a kind of comparison of all these different tools a bit later on. But for me, this is one of the major benefits of Fabric. We can just, in one line of Python, access an incredibly mature framework for data validation that's been used by millions of users. It's been battle tested. It's got a lot of people using it. And so it makes sense to just tap into all of these products and kind of apply them into our projects. This is where the first example notebook. So I'm not going to be going through the code. But again, if you look at the YouTube video that I published 10 minutes ago, and if you look at, well, I walk you through that and follow the link that I'm going to show you at the end, you can download this and you can get going with it today if you want. So the table and data frame validation is this bit in the middle. So we're moving between one Lakehouse table and another Lakehouse table, for example. Normally we want to do some sort of parsing, cleaning, transformation in between those two layers. And when we write it out to the next layer, we might want to do some validation on it, just to make sure that it meets certain expectations. And those expectations are going to be different depending on which of these layers it is, right? It's also going to be different depending on your data set, depending on what you're going to do with that data and specific columns in that data set further down in the pipeline. So here's what that could look like. We might grab our table, which is the raw table, bring it into a cleansing and validation notebook, do the cleansing, validate it. Then if it passes, well, we can write it out to our cleanse table. If not, then we kind of log it. Again, you have to implement some sort of data validation failure handling strategy. So in that one, it depends quite a lot what you're going to do there. It depends on the data. Every data set is different, and a lot of this comes down to domain knowledge. You need to think carefully about what you want to be validating. Specific columns might be more important than others. You probably know your data better than anyone, or at least someone in your business does. Make sure you're working in collaboration to understand what should be validated. Always think pessimistically, like if this column was 0 or minus 1,000, or this date was in the year 1 AD, for example, would that ruin all my analytics? Has happened before. Like I mentioned before, null values, especially in important columns, ones that you're going to use for something later on in your pipeline. Are the values in expected ranges? Categoric variables in predefined lists. So if your company does quite a lot around metadata management, you've got a very strict kind of list of dimensions and things for, I don't know, department name or region name, for example. Can you guarantee that any new data that's coming into your system conforms to those predefined lists? And if they don't, that should be flagged. Deduplication. If you're doing some sort of deep duplication exercise in your notebook, well, you want to make sure that it has actually deduplicated the files, and you've only got unique primary keys by the end of it. Now at this stage, we've got a few different options. Again, we can use the Python and the Spark ecosystem, Great Expectations, Pandera. But if you're using two kind of lakehouse tables, or a lakehouse and a data warehouse, we can also use SQL at this point. Who here has used DBT or heard of DBT? Awesome. So DBT is a third-party tool, but it integrates pretty well into Fabric. And we can use it predominantly for data transformations using SQL. So it's kind of that T in ELT. But along with that, we can also define validation checks that we can do as it's passing through DBT. So if we just look at this example, here, we're getting our data from the raw data warehouse. DBT is kind of accessing that data, reading it, doing the transformation, and then writing it into the next layer itself, at the same time validating it through, I think it's Ginger files. I haven't used DBT in a long time, but I'm definitely going to be exploring DBT more in kind of Fabric on the channel. So that's not something I've investigated much yet. But if you want to do SQL and kind of data validation through SQL rather than Python, it's definitely recommended. So finally, we've got the semantic model validation, right? So you've got a Power BI semantic model. How many people kind of validate their semantic models after they've published it? Yeah, a few people. Now, normally, from my experience, that's like opening up a report, making a new tab, and getting some data in a table, and then like scrolling through it a bit, and you're like, yeah, that looks about right. Publish. Well, unfortunately, I would say it's not really good enough. For me, semantic model validation means every time your model refreshes, you're getting populated with new data. Can you be sure that the tables are correct, the relationships are still kind of working for the new data, if you get what I mean? And the DAX measures are still outputting the correct results based on your new data every time that model refreshes. So this is what this could look like. We might have a gold data warehouse, reading it into Power BI, doing your Power BI development process, that spits out a semantic model and a report. And before we kind of let the user loose on this report, well, we can bring in that semantic model into a notebook. And we can read it in using semantic link. So semantic link is specific to Fabric, right? So it's well, it's not brand new, but it's a feature in Fabric. And there's a Python package called SemPy. And it basically allows you to look under the hood at this black box that is the semantic model. So you can bring out data, or the tables in your semantic model. You can explore the relationships. You can evaluate measures in your semantic model using Python. And you can evaluate raw DAX using Python as well. And so that, in combination with Great Expectations, means that we can pull all the stuff out of the Power BI semantic model and check that it's always conforming to what we expect. So just to summarize here, at this stage in the semantic model validation, we're validating that the DAX measures return correct values, that your semantic relationships have been defined correctly, including kind of like weird edge cases as well. Now the tooling is going to be semantic link, Great Expectations. And again, there's an example notebook that shows you exactly how to do this on my YouTube channel and on my school community as well. So we've mentioned quite a few kind of buzzwords and tooling approaches there. Let's just do a bit of a comparison side by side, just to give you a pretty clear indication of how they all compare, so that you can make a good decision for your business. We're going to compare against the different languages they use, the difficulty, kind of learning curve, whether I think it's a kind of enterprise scale solution, or you can just do it for a bit of a toy project at the side, cost, if that's relevant, and any notes. So with all these things, it is possible to code your own. If you've got a superstar Python programmer, well, not even a superstar, you can write fairly basic, rudimentary data validation checks, functions, fairly simply. Or even in SQL as well, it's also possible. Would I recommend it? Probably not. It's quite high difficult to get really good data validation checks, and you have to write everything yourself and then maintain everything yourself. For me, we can benefit from this huge ecosystem in the Python ecosystem. Great Expectations has 400 expectations that we can lift off the shelf, and it's probably going to cover 95% of your use cases, and that other 5% you can just create custom expectations. So I definitely recommend not coding your own. It's not enterprise scale solution either. You're going to have to implement your own logging, your own results writing, and all that kind of stuff. So can get into a bit of a black hole if you go down that route. Okay. Then we've got 3 different options that I mentioned around Python. Well, Pandas and Pydantic, these are actually quite easy to pick up. They're quite logical, kind of work how you expect. The problem with them, though, is it's quite difficult to scale to an enterprise level with them. They're good for, if you're a data scientist, like Pydantic's really popular in the data science community. If you're just doing like data sets that you're doing in your kind of data science workflow and you want to check that it's still the same structure as it was. For what we kind of want to do in kind of data architecture type stuff in Fabric, it's probably not ideal. Great Expectations is a better tool because you can get oh no, sorry, something just popped up on here. Because with the Great Expectations, it outputs a similar file format for the results. Every time you do some sort of data validation, it's going to give you a consistent structure. It's also got things like data documentation for all of your data sets that you validate. It's also got things like actions. It's got very feature-rich Great Expectations. But with that, it means it's quite difficult to learn. If you want to implement it properly, there is a bit of a learning curve there, to be honest. But I would argue that it's definitely worth it. And in my examples, I've basically tried to create very, very simple Great Expectations ways of, or workflows that I would argue are really simple. It's like 5 lines of code. You can validate a table. Next, SQL stored procedures. So it is possible, again, to kind of code your own in SQL stored procedures. But again, I wouldn't necessarily recommend it. Medium difficulty, you can do kind of quite basic stuff with SQL stored procedures, I would argue. Again, you can have to write your own logging and do all that sort of stuff as well. So it's difficult to kind of scale to an enterprise solution. You have to write a lot of stuff supporting it. Wouldn't probably recommend. If you are going to go down the SQL route, definitely check out DBT. Like, the popularity of DBT has gone up and up and up. And when I started using it 2 years ago, I used it for about 6 months. And I absolutely loved it. So I would definitely recommend checking that out, especially if you're using SQL, obviously. There is a bit of a fee if you want to use the cloud version of that, so bear that in mind. Can be a bit pricey, but yeah, make sure you do your own calculations on that. With Great Expectations, I've got free with an optional paid service. It's probably less required for Great Expectations. You can get away with the open source. All of the Python libraries that I've listed here are open source or have open source versions. Finally, DAX. So I have seen some people write data validation rules in DAX. Again, would not recommend that. Try and do as minimal DAX as you can. That's my way of thinking about things. Just because you can doesn't mean you should, especially now. We've got this whole ecosystem of Python tooling that's built for this kind of thing. I would definitely recommend doing that. So up until this point, we've been talking about kind of one data set passing through our pipeline. Now I just want to step back a bit and think a bit more strategically at a kind of enterprise level. We might have one data set flowing through our system, but in reality, you've probably got hundreds of pipelines like these. So how do you manage and monitor all of these different pipelines across your organization, right? Here's one idea. So again, we've got this kind of layered approach, different lake houses, a raw layer, cleanse layer, enhance, gold, semantic model. And if we use one tool for our data validation, for example here, Great Expectations, then at each stage we're kind of moving through these different layers, we can write out validation results. So that's going to tell us how many rows in that data set pass and fail for each test. And we can write that centrally. We can create a new lakehouse for storing our data quality metrics, right? And that's going to become a really valuable data set for your organization. And on top of that, you can build data quality monitoring reports so that you get this kind of enterprise level analysis of what's going on across hundreds of different pipelines, potentially. Another idea is that you could use that for your enterprise data docs as well. So documentation that you get basically for free with Great Expectations. So every time you define a validation check, it's called an expectation in Great Expectations, funnily enough. Every time you define an expectations, you're saying this column I expect to always be this, whatever, for example. And that becomes quite a useful piece of information in terms of documentation, because someone new can join your company, and if you've got documentation that says, okay, these are the 20 data sets that we've got, whatever, maybe more, but these are the 20 data sets we've got, and this is how we validate them. They can go into the data set, and they can say, okay, this column must be important, right? Who's joined a new company? It takes you about 3 to 6 months just to understand what the important columns are in each of the tables in your database. So the key point here, if you want to do that, is it helps if you only use one tool. So you choose one tool and stick with it, because then it's going to export similar kind of validation results, okay? I mean, it is possible to do multiple tools, but then you have to pass each of your validation results slightly differently to write it into that central lakehouse. I recommend Great Expectations, because you can do all 3 types, of the three types that we've mentioned, so the source file validation, lakehouse table validation, and the semantic model validation, did all of those with Great Expectations. And all of my implementation notebooks that I've published use Great Expectations. We can put all of those validation results, we can save them into a central lakehouse. So that's for all checkpoints and all pipelines. And on top of that, you can build your Power BI report that kind of presents back to key people in the business, maybe not everyone in the business, but people that are monitoring data quality, present back to them what's going on and look for trends, and ultimately so that you can identify where you need to put your investment, invest more time into improving your data pipelines. You can also use the data docs functionality to document all your data sets that you're validating. And these can be written into the actual lakehouse, and you can build a Power BI report that showcases that documentation back to your users. Okay. So to finish off, I just want to talk about a couple more features in Fabric that you can use to, well, in this kind of data validation space. They're not specific for data validation, but we can use them for that. So if we take this example that we've just been looking at, you've got your data quality monitoring report at the top here. Now what we can do is build a data activator reflex. Who knows what a data activator reflex? Yep. So what it's going to do is it's going to monitor a certain visual in that report, and it's going to look for a condition. So you can say, you can put any condition you like, but it could be a failure event, right? So you've got all of these validation results feeding into that lakehouse, into that report, and any time one of your validation sets fails, it triggers this failure data activator. And from that, you can either do notifications, maybe even create a JIRA ticket, assign it to someone, say go and have a look at this pipeline, it's failed, or the data quality has failed, not necessarily the pipeline. So another aspect that we could look at tying into is data governance. Obviously data validation, data quality is very related to data governance, and Fabric has data governance features that we can benefit from. So if you've got that gold data warehouse, if you just think about the gold layer, for example, by the time it reaches there, it's gone through quite a few different checks, right? So we can be pretty sure that that's of good quality. And so what you could do is certify that gold lakehouse so that people in your business, you can say, right, these are the data quality checks that have all happened to that data set up until this point. We're going to certify it, and so that anything you see in that warehouse, you know it's got a bit of a stamp of approval, and you can use it for any sort of semantic modeling in your business. And you can do the same for semantic models, right? You might want to only certify semantic models that have been validated and are always validated every time they refresh. So just to basically look at validating your warehouse, if you go to the settings of the warehouse, you can just click on certified, and to do that you have to enable it in the admin portal if you haven't already. And when you enable it, you can actually specify a URL for documentation, which is this bit here. And again, another idea is that you could point that to your Great Expectations data documentation. Okay. So the next steps, just to summarize here, everything that you need to know to kind of embed data quality into your pipelines. At the beginning of the session, I kind of asked how many of you have been embedding data quality and data validation into your pipelines. About 4 or 5. Hopefully by the end of the session, a lot of you will at least understand the importance of data validation, and hopefully I got across some of my passion for it. And I think it should be right at the heart of your Fabric data strategy, right? It should be the foundation layer. Before you do any of the fancy stuff, you need to guarantee that the data that's passing through your system is of good quality. And then you can worry about your fancy DNEB visuals and your machine learning models and all that stuff. To do that, you need to design the right architecture. You need to think about data validation when you're architecting your solution. And we've looked at some ideas of what that could look like in this session. Then you need to think carefully about what you're going to validate. At each stage in your pipeline, helps if you have that domain expertise, or at least access to someone with that domain expertise, to understand what you should be validating. Make sure you're choosing the right tools. We've looked at different tools that you can use. That's going to be different for each company, depending on skill sets, cost potentially, different flavors that you've got in your organization already. Then you want to think about setting up enterprise monitoring. Maybe you want to build a central metrics lakehouse. It's going to write all of your validation results into. You can build some reporting on top of that. You want to think carefully about how you're going to handle failures. Finally, you might want to tap into that certification in Fabric so that you can really understand, or people in your business can understand what's been validated and the data sets that they can really trust. Thank you very much for listening. Take any questions. And if you can, leave some feedback. That would be awesome. I think there's prizes for people that leave feedback. It'd be really good to hear some feedback. It's my first time presenting at SQL Bits, so would love to hear what you think. If you want to... Oh. Yeah, and if you want to reach out, then these are my details. The middle link here, school.com/Microsoft Fabric. That's the one where I've uploaded all of the notebooks and all of that stuff. It's all for free, so I'll grab it from there. Any questions? Oh.
Hi. You know whether you can use dbt only as a data validation tool, or you can only apply validations in dbt to transformations written in dbt?
Okay, so the question was, can you use dbt just for the validation?
Just for validation, yeah.
I believe so, yes. It's been a bit of a while since I used dbt, but yeah, I think you don't have to write it out to a different layer in your architecture. You can just use it for the validation, yeah.
Okay, thank you.
So the question, as I understand it, was why should you think about using dbt if you're using kind of SQL stored procedures in a data pipeline? Yeah. It's a good question. dbt has a lot of extra features built on top of it, right? So if you're just using SQL script for transforming data, that's great. Also has a lot of things around data lineage. It's got the data validation stuff ruled in. Before Fabric, it was maybe even better because you could do like Git integration, source control, all this kind of stuff. It kind of gave birth to what some people call analytics engineering, that analytics approach to SQL, basically. So there's a lot of features there. I haven't used it for a few years, so I can't like give you a really good answer, unfortunately. But yeah, I would just recommend having a look just to understand the capabilities and then make your own decision. Yep.
Hang on, hang on.
Hang on.
You're getting the mic.
With things like the schema validation to bronze, let's say, how would you weigh the effort it takes to really go to your source, get the schema, do all of that validation in terms of how many issues there really are when just having your data into bronze or loading it into bronze?
Yeah, so the question was when you're reading data in from the file, kind of that schema validation, is it worth the effort is basically what you're asking. So I would argue that yes, it's definitely worth the effort. It doesn't take long to set up these kind of routines. If you go to like the example notebooks, it's only a few lines of code, and you immediately know whether every time you pass in a new file, you're going to get a flag or kind of a data equality validation error that's going to immediately pinpoint you to the problem, right? It's going to say, well, this column here is not called this column anymore. And if you don't have that, it can take quite a while, in my experience, like trying to debug these things. Like sometimes it's a bit difficult and hidden. So it makes that easier, and I'd say in the long run, it's definitely adding more robustness into your process. I think you should be managing like schemas in general. You know, there's lots of ways to kind of manage schemas throughout your business, especially on incoming files. You can add your schemas into a dedicated like schemas area, depending on how you want to save them. Then once you've defined them once, you're just reading them every time. Like you're not generating the schema on the fly. If that makes sense.
Yeah, it does. Thanks.
Thanks. Any more? Okay. Well, I'm actually having a session at 4:20. There's like an Ask the Expert session, I think downstairs. So if any of you are around and you've got any more questions, then I'll be around at 4:20 at the Ask the Expert session. Thank you very much for watching. Enjoy the rest of the conference.